All right, so we are doing triangle congruence. This is day 1. This is target 3C. All right, so your learning goals for this lesson. You can use your previous knowledge of angles to determine missing angles of a triangle and use triangle congruence rules to prove two triangles are congruent. This last one is a big one, so make sure you're taking really good notes here. And so therefore this video might be a little bit longer, but I'll get through it as quick as I can. All right, so here we need to find the value of y. So first things first, remember that if two sides of a triangle are congruent, then the angles opposite those sides are also congruent. So we're told here, let me change the color so you can see a little better. We're told here that these two sides are congruent. That's what those marks mean, don't forget, which means that angle x and angle z are also congruent. So we need to find x. We know that x is supplementary to 120 because we have this straight line here. All right, and that means that 120 plus this adds up to 180. So all we have to do to find x is subtract it from 180. So 180 minus the 120 that we know equals 60. Now because x and z are congruent because of what we know up here, we know that z is also 60 degrees. And then all you have to do is remember triangles have 180 degrees in them regardless of anything. So if we know that this is 60 and we know that this is 60, all we have to do is do 180 minus 60, which will give us y equals 60 degrees. Now it's not, y isn't always going to be the same as this, so be careful. You have to find out what x is. That's what z will be. Subtract those two numbers from 180 and that'll give you y. All right, now into the harder part. The most popular congruent figures are triangles. If two or more triangles are congruent to each other, they have 3 sets of congruent sides and 3 sets of congruent angles. So as you can see, all the sides are congruent, all the angles are congruent. Angle A and angle D are congruent, angle B and angle E are congruent, so on and so forth. All right. So looking at our example, AB is congruent to DE, BC is congruent to EF, AC is congruent to DF, and then the corresponding angles are also congruent. Make sure that the names are in the right order, so like AB, BC, so on and so forth. All right, lots of ways to prove triangles congruent without having to prove every single part of this. As long as you use one of those ways, some combination of that will, once you prove the triangles are congruent, all the rest of it just kind of falls into place. So the first is side, 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 which you can abbreviate SSS. If 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent, which would mean that like angle A would be congruent to angle D, angle B would be congruent to angle E, and angle C would be congruent to angle F. The other way is side angle side. So if 2 sides in the included angle of one triangle are congruent to the corresponding parts of another triangle, then the triangles are congruent. So the included angle is this angle that is formed by the 2 congruent sides. So it's the angle that's in between. So included, you can think of that as meaning in between. So if we have side angle side, that's in between the 2 sides. Okay, included angle here, for example, angle G is the included angle of IG and GH. Angle I is the included angle of IH and IG. Angle H is the included angle of IH and HG. Now, angle side angle, if 2 angles in the included side of one triangle are congruent to the corresponding parts of another triangle, then the triangles are congruent. So the included side is the side that is in between the 2 angles. Just like in the last one, except now it's a side that's in between 2 angles, not an angle that's in between 2 sides. Included sides, here's some examples. I would suggest writing these down so you know at least one of them. And then last we have angle, angle, side. If 2 angles in the non-included side of one triangle are congruent to the corresponding parts of another triangle, then they're congruent. So the side is not in between the 2 angles. It is one of the other 2 remaining sides. So here's some examples of that. Okay, only these combinations are going to work. How come the other ones don't work? Because there are some other ones that you could think of, like side, side, angle. Well, these are methods that do not prove triangles to be congruent. angle, angle, angle. You could draw two equilateral triangles that are the same shape but are not congruent. So keep that in mind. You can maintain angle congruence, but the side lengths would be different then. All right, next we have side-side angle. Here's an example if you look at this, where we have two sides and the non-included angle could result in two different triangles. Okay, something to note, once you have proven that triangles are congruent, the remaining corresponding parts are also congruent. So let's look at the second example. We want to complete the triangle congruent statement and write what postulate we used. If triangles cannot be proven congruent, state not possible. So if it's one of the ways that I just went over, it would be not possible. So if we look at this one here, we have an angle congruent, and then we have two more angles congruent. So we really there's only one postulate that states that has two angles that we could use. Well, there's two. There's angle, angle, side, and angle, side, angle. So we need to figure out which one it is. So we've got an angle. Now we can say that this line is congruent. So this is the included side because of the reflexive property. Remember that. So we're saying that this is congruent to itself. It's part of both triangles. So we have angle, side, angle. And then you have to make sure that you name it correctly. So triangle STV is congruent to triangle UVT. So we went from S to the first congruent angle across the congruent side to the second congruent angle. So S wasn't congruent to anything in our initial part, so you're going to follow that same pattern here, UVT. Last example, we have to complete the missing steps of each proof. So we're given that segment AB is congruent to segment AD, and we're told that segment DC is congruent to segment BC. And we need to prove that the triangles are congruent. So remember what we learned about that, about how to prove triangles congruent. So we write our first two steps as our given. This is one step. This is the second step. Keep in mind that you can write this as one step if you like. I just wrote it as two separate ones. In that case, you would eliminate that and you would only write given once. And you don't, when I said you'd eliminate that, you'd eliminate the number. You'd still write this part. And then we know that AC is congruent to AC, and that's by the reflexive property, because remember, if you have something congruent to itself, even if so basically the same two letters, that's the reflexive property. Now we've got 1, 2, 3 sides of this one, 1, 2, 3 sides of this one, so the reason would be side, side, side. All right, a lot of information to take in, so hopefully you were pausing, taking good notes. You need to know these triangle postulates, so make sure you have notes on all of them. And that is it. Look for the next video, which will be much shorter, I promise.